Good morning friends, I am back again with one more video lecture on the topic equations reducible to linear form. Now the general equation reducible to linear form is f prime of y, this is the derivative of f of y, dy by dx plus p times f of y is equal to q, where p and q are the functions of x and y or constants. Now this equation is denoted by 1. Now this is not a linear differential equation. Now this equation 1 is not a linear differential equation, but it can be made to linear by the substitution. Let this f of y is equal to v, and differentiating these with respect to independent variable x. Now derivative of this f of y, answer is f prime of y times derivative of y dy by dx is equal to derivative of v, answer is dv by dx. Therefore, now equation 1 becomes this f prime of y dy by dx, answer is dv by dx, plus p times f of y, answer is v, is equal to q, which is linear in v and can be solved easily. Now we will solve one example based on this technique. Now example is solve the differential equation dy by dx plus x times sine 2 times y is equal to x cube cos square y. Now dividing this given equation by cos square y, 1 upon cos square y times dy by dx plus x sine 2 times y upon cos square y is equal to, in RHS, cos square y upon cos square y get cancelled. Now 1 upon cos y, answer is sec y, therefore 1 upon cos square y, answer is sec square y times dy by dx plus x. Now sine 2y, answer is 2 sine y cos y upon cos square y is equal to x cube. Now 1 cos y get cancelled from numerator and denominator. Now here is x times 2 means 2x, and sin y upon cos y, answer is tan y is equal to x cube. Now this equation is denoted by 1. Now let this tan y is equal to v, and differentiating this with respect to x, the derivative of tan y, answer is sec square y times derivative of y dy by dx is equal to derivative of v dv by dx, and therefore equation 1 becomes, now this sec square y dy by dx, answer is dv by dx plus 2 times x, and this tan y be the v is equal to x cube. Now this equation, which is linear in v, it is denoted by 2, and p equal to 2 times x, and q is equal to x cube, and therefore integrating factor if is equal to e to the power integration p dx is equal to e to the power integration 2 times x dx. Now integration of 2x, answer is 2x square by 2, the 2 get cancelled, answer is e to the power x square. Hence general solution, hence its solution is v times if is equal to integration q times if dx plus c. Now here if is e to the power x square, is equal to integration q. Now q is x cube and if is e to the power x square dx plus c. Now integration of x cube times e to the power x square. So we write this x cube as x square times x. So we write this x here, x times dx plus c. Now substituting this x square is equal to t. And therefore, this 2x dx is equal to dt, that is x dx is equal to dt by 2. So therefore now this v be the tan y times e to the power x square is equal to integration. Now this x square be the t, e to the power x square again e to the power t times x dx, answer is dt by 2 plus c be the constant of integration. Now this is equal to half integration t times e to the power t dt plus c. Now applying the integration by parts, that this t be the first function and e to the power t be the second function. So this is equal to half this first function as it is integration of t minus integration derivative of first function integration of second function dt plus c. This is equal to half t times e to the power t minus integration. Now derivative of t, answer is 1. Integration of e to the power t, answer is e to the power t dt plus c. Now this is equal to half this t e to the power t minus integration of e to the power t, answer is e to the power t plus c. Now here e to the power t is common, t minus 1 plus c. Now this t is x square, the answer is half e to the power x square. T minus 1, the here is x square minus 1 plus c. Now dividing by e to the power x square, this tan y is equal to half x square minus 1 plus c times e to the power minus x square, which is the required solution of the given problem. Hope all of you have understood this problem. In the upcoming lecture, we will discuss Bernoulli's equation. Please subscribe the channel and let me know your comments and feedback. Thank you.